Hello friends, सबको नमस्ते. So today in this video we will create an image classification web app, and for that we use multiple models, dog versus cat and flower, and the framework which we use is Torch. Okay, so let me first show you how our web app look like. For that, go to the terminal and just type Streamlit run app.py. It will automatically open your browser with the web app interface. See, this is interface, and the default model selected is dog versus cat. Let me first now select one image. Oh, this is not. Let me first select dog image. Okay, then we have to click on this for the for running the classification. You can see this stock 100% model. Use this. Now let me select different model. Now model I have selected is flower. Now let me select one image for the flower. Okay. Let me select this image. Okay. See, Dandelion 99% surety model use flower.pth. So this is a web app which we will create with multiple models. So now let me explain the whole code. Okay. So these are the package which we'll use. This is we do not use NP here this time, and this is a data or you can see the dictionary which of multiple models. This is a keys dog versus cat, flower, class names dog versus dog and cat, weight name cat versus dog. That's weight name is basically come from here. You can delete this. This is just a okay. So weights come from here, cat versus dog, flower.pth. Okay. And this is st.set page config, page title, image classification, and layout white. This line basically is for this one here. This is image classification, and the width will be white. Okay, so this for this is a page configuration. Now to display this background has this dark background, like this image as a background. You have to use this. First you have to give the path, then just call this gatway64 image function, because we have to encode it the image so that we can easily display that image as a background in a Streamlit web app. Now we will open this image in a read binary format as image file, and when using with this base64 and base encode, we can encode it, and we get the encoded image. After getting the encoded image, we will store that encoded image in this variable, and to display that image in the background, we will use this css st.markdown, and this is a css style.st.app, where this st app is for the entire web app. Okay, now background image, then this way you have to give the image, then size cover, position center, no repeat. This way you will set the image as a background. Now now here we have to set the title, this one. To set this title, you can see this is we will use st.markdown, div division, then class title, image classification using pretrained model, means text, unsafe, allow stable true. Now here this is a class, and the css for this is this one, st.markdown style dot title means class, then this is the css. And you can see that here is margin top is equal to -60 pixel. Why it is? Let me erase it, then save this, then again run the. you can see that if I will not use minus 60 pixel, the margin from the top will be increased. You can see that margin from the top increase, and if I will use that minus 60 pixel and again run this, okay, then margin from the top will get decrease. Okay, see, margin from the top get decreases. Okay, so this way we set the title. Now we have to set the selection, means drop down box. Okay, for the selection, we use st.selection, then the text which we want to display, and which all but text you want to display in a drop down. We want to display uh, this keys data versus dog versus cat and flavor. We have to display this as a drop down. So for that, just data dot keys will give me the keys of all the of the keys of the data dictionary, and then we convert them in a list. And one more thing, that the default model which is selected is the first key is dog versus cat, and this data for that is stored in this. Means when we use model name, means the key which is default selected, then this whole information, this class name and weight name, uh, will store in this model data variable, now we have to use the uploader. For that, we use st.file uploader, then the text which we want to display, and the type of the images which we apply is JPG, JPEG, and PNG. Okay, and whenever the user upload the file, then we open that image, and here the meaning of the prediction is initial value will be returned. Then I will explain you the meaning why we had to use this prediction and below code. Okay, so don't worry. Now see, you can see that. Uh, Let me select one image so that see, we have a three column, one for the uploaded image, one for the button, and one for the prediction. So for that, we have created three column 1, column 2, and column 3. These are the columns, and these 1.2, 1.1, and 1.2, these are the width of that columns, and the gap between this column will be large. Now in column 1, we are just displaying the image. You can see that we are just displaying the image. For that, just use st.image, then pass the image. The container width will be true. Caption which we want to display below the image will be uploaded image. Now in column 2, you can see that in column 2, the button display and the margin from the top is of about 2 br through the HTML. So we use CSS br for the margin for the top, and after margin from the top, we will display this button. If st.run button, and then this button will be there, and the CSS for this run classification is this. You can see that style div.st button margin from lab will be 30%. And why we have to use if here, because whenever the user click this button, this will get activated, means spinner will come, and when a spinner will come, classifier function will get activated. And classifier function, you can see we are passing image, model data, and weight name, and a class name. So it's come here. See from where it's coming. Model means model folder. In model folder, we have a init. I have created the init file. You can see that from dot classification, means folder, means from classification folder, in its classification folder have a classifier Python file, and inside the classifier Python file, it have a classifier function. So classification, classifier Python file, and inside it has a classifier function, and parameters is image, weight name, class name. Okay, and class names. Okay, so So the first step is that we will first have to create the architecture of the CNN model. For that, we have created the CNN object of the CNN model. Okay. So from where the CNN coming, you can see that from .cnm in the fold means from the file, Python file, and it's have a CNN class. You can see the CNN, and this is the architecture of a CNN model. Okay. And after creating the object of the CNN model means architecture without the weights. Okay, now we have to create the weight path. After creating the weight path, uh, we have to load the weights. So here we are loading the weights, torch.load weight path. Then map location is CPU, because right now I'm not using GPU, I'm using CPU. So that's why. Now here we are to load load dot state of date and state date. Okay, this way we have load the weights file. And after this model dot evaluation, because now model is in a evaluation mode, not in a training mode. Then pre-processing, because all the pre-processing had to apply on the image, which is necessary. Okay, so what is things? First thing is to resize the image, and second thing to convert the image into tensor, because we are using torch, and torch we have to convert that image into tensor. Then apply the transformation, then return the image. After cutting the image, we have to unsqueeze 0, means I already told you that in all my videos I told you that during training we pass the image as a batch. So at during test time also you have to pass the image as a batch, and you have to use unsqueeze to add a batch dimension in the image. After adding the edge dimension, just pass the image. Now, after getting the output, we have to get the index value on which the highest score is present. For that, we use torch.argumentMax and then pass the output dot item. This line will give me the index value on which the highest probability or highest score is present. And using this, we can easily get the class label name. After getting the label name, for getting the score, just output dot zero. Then the prediction means the index value on which the highest value is present. You can get the score of that. Okay, now after getting the score, we can round it to the after multiplying with the 100, we can round it to true value. And ultimately it's a float value right now, so you can see this, it's in a float value. And then after converting it into int, we can get an int value of that score. After getting this label and score, the compiler went again here, label and score, and here prediction. Now starting value will be none, and here when you get the label has a tuple and tuple with label and score, this column 3 will get activated. Means now here it's, if prediction means prediction have some value before it is none, when in column 2 its value will come, label and score and it's activated, means prediction gets some value, it's this column 3 got activated. And after that we have to fetch label and score and just display the prediction. So this is a whole code which is useful with multiple models. So now let me again show you the result. For that, just type Streamlit run app and your code will get start. See, default model selected is dog versus cat, but now I will select flower. Then let me select one image. Let me select mm, perfect image. I want to select this image. Let me select this image. This is Dandelion. Then run classification. You can see. Okay, Dandelion. Now let me select one image of Daisy. Then again run classification. Daisy. You can see that it's working. So this is a web app. Now you can easily deploy it, or you can use anywhere. You can share the link of that if you deploy it. Okay, so this is a whole code which I had explained you line by line. So please like, share, and subscribe. Thanks to all.